Okay, welcome to the Electron Injection Podcast, the podcast with no listeners. Okay, if you are a listener, give you a shout out. I'd like to see if I have one yet. I mean, we're a vastly growing organization. We have 30,000 members, and we're a very big deal. Why is it being a big deal makes you a bigger deal for whatever? Forget about it. Anyway, so I'm actually redoing this podcast. I did it about an hour ago, and it had tons of noise and crackle type stuff in it. Well, why? Because my synthesizer is now plugged in my audio interface. And that was a big deal for me. I was all excited to do that this week because before I had my own little custom audio amplifier, a little cheapo crappy thing that I was using to test my synth. And I did that mainly because if I blew something up and put 700 volts through it, I didn't really care if it died. But over time, I hate to say confidence has grown, but over time, I've become numb to the dangers of my own synthesizer, and I was cool with plugging it into my fancy audio interface. And I'm really thrilled I get to redo this podcast. One, because I love hearing myself talk, but also I found the new problem. If you plug a synthesizer that's turned off, has no power going to it, into an audio interface or a mixer or anything else, it should not be going. And it was a lot of noise. So I have something wrong, and now I can fix it. And I would love if everything that's wrong with my synthesizer would be, obvious to me, so I can address it and learn how to solve it. I don't want to get the thing done and sell it on Amazon and then decide I have problems that I need to fix, which will ultimately probably happen too. Okay, so speaking of the synthesizer, old Reagan's Revenge, I hooked it up to the MIDI controller. I don't know, YouTube people might be able to see a little keyboard back there. It's pretty cool when you start playing around with a chip and you start making a thing. And then it's like, for me, the synthesizer has been a long time coming. I've been working on this for almost a year. And now I get to plug it into a keyboard. I actually get to play. And I don't take I'm not a musician. I was a recording studio guy. That's what I called myself for years. And so I beat on keys a little bit. It's terrible, but I got to play like 20 minutes, and I actually got to have fun with my synthesizer. And that's something that's interesting. It was working reliably enough where I could actually like kind of forget who I was and just play stuff. And that's a start. And I guess that's the dream. That's the hope. So anyway, it was really nice being able to get to that point. And again, we got plenty of bugs and all kinds of stuff to fix. What else is new? But at least I can play the damn thing. How about that? I made a synthesizer that's playable. So that's kind of cool. Now, last week's YouTube video, moving on, was can you reflow solder in the kitchen? For you people who don't know what reflow soldering is, that's when you spread this toothpaste type goo. It's like the consistency of toothpaste over your pads on your circuit board, your PCB. And then you put all your surface mount components on those, just drop them down, and you heat them up, and then they will automatically, if you do everything right, snap. The components will snap into place. It's almost magical. It's pretty cool. Well, they are supposed to snap into place, but a lot of times, if you apply just a little bit too much, or if the component you're dealing with has very low mass, very low weight, then it's possible that it will actually the effect will shift the component in the wrong way and maybe flip it off the board and flip it sideways, and basically your circuit's dead. That's a possibility. So the solution to that, well, a lot of people use ovens to do it, and the ovens are cool because they get heat from the bottom and the top. It's uniform and all this, and you can program these ovens to meet a very specific temperature curve. Heat it up at a certain rate, cool it off at a certain rate. And all the chemist type people have figured all that out, what's best. In real life, though, no one does that with the regular solder stuff. You just heat it up and then take the heat off. Maybe regular solder has different circumstances. I don't know. But either way, you can do the reflow yourself without worrying about all those thermal profiles for heating and cooling, and it usually works fine. Now, if you're Apple and you're going to make 100 billion iPhones, maybe then you need a very specific process just to guarantee that 1 out of a million doesn't mess up. But anyway, in real life, for us, working at home type people, hobbyists and unemployed engineers, or whatever you call us, you stick that component on. If it goes the wrong way, well, if you heat it up on a plate instead of an oven, well, now you can use your hand. Well, tweezers, or your hand, I guess. You can use your tweezers and you can adjust those components, and then they'll pop back in the other way. So if they're a little bit too far out, they round the wrong way, but you can round them back the correct way. So that's why I've gotten into this type of method. Well, I really just tried it out, I guess. But I like the heat from the bottom approach, because then I can fix anything that goes wrong on the fly, like right then, without having to resort to hot air. Hot air guns, another way where after you use an oven, if you pull it out, well, then you got to heat that part back up. And I don't like getting the parts hot. And a lot of times you heat up things you don't want to heat. Heat guns have air, and they blow air, so they will blow light components off, like capacitors, resistors, LEDs. They'll fly right off if you're not careful. So there's a lot of downsides to using hot air. And so this is why I like the idea of heating the bottom. Now, some people do a combination where they heat the bottom lightly and then just and then use the heat gun sparingly as they need to. That's another way to do it. And actually, I haven't tried it. The solder paste that I use is like 137 degree melting point Celsius. So it melts like way, way lower temperature than normal solder does. And so maybe that's the big secret to making this work. Not sure. But anyway, the video is, can you reflow solder in the kitchen? And so the wife was gone, and I was like, you know what I'm doing? I'm grabbing me a piece of aluminum. It was just a little thin 1 millimeter thick one, and I'm slapped that up on the burner of the stove. And then I slapped my PCB down, and I just turned it up to kind of like a light medium, I guess you could call it. Lighter than I often cook with. And I waited a few minutes, and then you start to see the goo. It turned into, before you know it, it transformed into solder. So it worked. I saw zero downsides, except for one, the wife has to be gone. She just doesn't like that idea of having my stuff in her kitchen. That's what it boils down to. In her defense, I do have like a wood shop, my workshop downstairs, and a garage full of my stuff that's all Brando toys. So I guess I can give her the kitchen. When she's not there, though, I'm taking it back. So anyway, so I did it, and I thought it was great. There is a smell. The wife would notice a smell and go, "What are you doing in my kitchen?" And I noticed that same smell in my dungeon here too when I was using my workbench to solder this thing. So I didn't think it was that big a deal within my standards. I think I have a sensitive nose, or a really good nose. It's not sensitive; it's tough. Either way, I didn't think it was that big a deal. So, you play that by ear, but if you ever need to do reflow soldering, just using a little piece of aluminum, spread the heat out evenly, and a PCB is doable. I didn't see any reason why this wasn't totally viable. And the fact that they sell those hot plates and people use them, kind of suggests it's a doable thing. It's more like, do you want to put a piece of aluminum to touch your stove or not? That's up to you. Okay, what else we got here? Okay, this was on the Embedded FM podcast, a podcast I recommend. It's embedded systems programmers usually. They're not double E's. They're not electrical engineers. They're programmers. They're way better at functions and interrupts than I am and people like me are. Not soldered as much as I probably have. No big deal. Not tooting my own horn, but no. So they come from the embedded world, so they understand chips and microcontrollers, but a little less up on the hardcore double E stuff. But somebody, they had a really cool topic, and I wanted to chime in. And once again, they wouldn't let me give my opinion, and so I'm just going to give it now. They were talking about a guy who had a background in programming, like, I don't know, Java or something. And he wanted to start playing around with hardware. And so he got an Arduino Uno and went to town and loved it. And so now he's like, well, I want to select a platform, meaning, like, I want to choose a family of microcontrollers, basically, where that I can learn this one platform and make everything I ever want to do. And then he started looking and he's like, oh my God, this is very stressful. Well, I think it's stressful for a person who wants to pick up one platform that does everything. Because he was trying to, almost like he was learning a language. Like, I'm going to pick English because that's where the money is or something. Where it's where the military, whatever. And then that would make sense. But this is not a microcontroller you can switch back and forth. And it's not free. And it's not without, wasted time and, investment in terms of learning curve and whatnot. But if you can program a EFM8, then jump into an STM32. I mean, it's the kind of thing, there's always gotchas and little things you might forget about. And you'd definitely being seasoned in one particular family of microcontrollers and learning it in and out makes you vastly more efficient than doing a new microcontroller for the first time. But that's kind of it. I mean, if you can program one, you can program the other. And whether you're using bare metal C or Arduino or whatever, in general, there aren't too many gotchas. So I guess my point is I had a totally different take on it than this new programmer guy was thinking. Like, just jump in. Don't stress out about it. You don't have to worry about it. You will have to switch platforms. You will use different microcontrollers for different things. And I'll give you a good example. You know, I talked about this in a previous podcast about how much I like the STM32 Blue Pill. I think at least before the Pico, the Raspberry Pi Pico came out, which I haven't got one yet because no one can get them. But before the Pico came out, I was big on the STM32 Blue Pill, and I still am, I guess. And I try to use it for everything. It's my go-to. And I like STM32 for many reasons, but one is if I get good with the STM32 Blue Pill, then I can bump up to their super ultra mega high speed dude, or I can go down to their super low power microcontroller. So I like the idea of being able to account for most needs through one family. That's really good to me. That's important. It's helpful. Time saving. But with that said, I'm not aware of any STM32 with Bluetooth or Wi-Fi. So what do you do? Well, you use ESP32, totally different microcontroller. And ESP32 is awesome because it's powerful enough to do like low-level video stuff. It's like, well, that's pretty cool. But it has a downside. And the ESP32 is it uses a lot of power when it's running, particularly the Wi-Fi. And so you might say, well, I don't care about that. I'm just making stuff on my bench. Great. But the second you come up with your Wi-Fi or your Bluetooth gadget, your MP3 player, whatever it is you're making, and you take it on the go, you take it out for a run or something, take it out camping, and the battery dies in 23 minutes, and you go, what the hell? And you go, well, now your project suddenly needs low power solution. Now, ESP32s can be put to sleep, but so it's more during use in that particular case that they use a lot more energy than a lot of microcontrollers. Now, this is not a knock on the ESP32. This is just accepting that all microcontrollers have quirks. They have pluses and minuses, and that's kind of the deal. The project will define these pluses and minuses that matter to you. And like I said before, low power may not be a thing you care about at all because your particular project plugs in the wall. Who cares? I mean, in general. But suddenly, pulling 180 milliamps for a few seconds matters. And so you're like, whoa, if you're, out camping. And so you have to really kind of account for the per project parameters that define your microcontroller. So you want to kind of pick something that's fairly broad, that will handle most needs most of the time. But a microcontroller, in the end, you're not going to find one that's perfect. There ain't no best microcontroller. So don't sweat it. And for all I care, just stick with the Arduino Uno. Arduino Uno is a great little microcontroller for most people most of the time. It's never going to be fast enough to do video, and it doesn't have Wi-Fi or Bluetooth, although you can add those with SPI. But I guess start with the basic one, start with the easy one, and there's no reason to stress out or switch until you need to stress out and switch. And even then, you don't need to stress out. You just go online and look. And a lot of people are going to recommend either ESP32 or STM32, which are the two microcontrollers that I like the most, I would say. So again, don't sweat it. Don't try to find the magic bullet because it doesn't exist. And just accept the fact that if you're going to switch, you're going to have to do some digging. But the good news is with this microcontroller business, especially like the popular ones, they've been used so many times in the past. Like there's so many tutorials, so many YouTube videos. This has all been done, so people can walk you through all of it. All right, on Twitter this week, remember I'm on Twitter, Brandon_Drury, DRURY. I'm actually still using Twitter. I've been hit with a few political temptations, and I dove in and then dove back out. No politics on Twitter for me. At least, maybe not none, but we're going to keep that at bay. That's for electronics only. Anyway, a guy mentioned that he has a J-Link, which is a programmer. It's a debugger. Programmers/debuggers are kind of the same thing nowadays. That's the gadget you plug your microcontroller into from your computer so you can program it. Now, Arduino has a programmer built in. It's you just don't see it. You don't notice it. There's actually two microcontrollers on an Arduino Uno. But so this guy was saying, hey, where's the power at? I want to power my microcontroller with this thing. And this is something that I think it really separates a beginner from somebody who's been doing this a while. Especially, and with me, I started with Arduino Uno. You hook up the Arduino to the USB, and then you power all your LEDs and all your other circuits and stuff, even relays, directly right off the Arduino. And then when you do this for a little bit, you start blowing stuff up once your circuits get big enough, like especially with relays. Anything that pulls some real current, you go, oh. And the Arduino Uno spoils us, because the Uno it turns out the ATmega 328P microcontroller is very, very tough. And it can actually drive LEDs. That's in the data sheet. I think it can drive like 20 milliamps LEDs, and that's a lot, I think. Don't quote me on that. Look it up, boys and girls. But for most microcontrollers, like the STM32, you wouldn't even think about driving an LED. It wouldn't even occur to you to drive an LED directly with a microcontroller. You would use a MOSFET of some kind, or in one way or another, the power is not going to come directly from the microcontroller. The microcontroller will turn on the switch, the MOSFET or transistor that lets the current flow, but the current is never going to come from the microcontroller. And so this is a kind of a bigger topic, but on the Twitter thread, it kind of turned into, people recommending using a real power supply to power the whole circuit, and so that way no power has to come quote unquote out of the microcontroller, or through, it might be a better word. But I even said, well, I couldn't imagine working on any project where my power supply didn't have current limiting. And current limiting, and this is when you have a fancy pants power supply, like you YouTube people might be able to see right here. That's a Reagan. I probably paid $300 or $400 for it. Totally worth it. Game changer for me from going from, I don't know if you want to call it hobbyist, to somebody serious, but highly recommended, because anytime I fire up a new board, I set the current limit to like 100 milliamps. And even if I know it's going to pull 1 amp, we'll say, like it's supposed to pull 1 amp, doesn't matter. I set it to 100 milliamps, just turn it on and just see what happens. And you won't hurt anything. What will happen is the voltage will pull down. And so, anyhow, the good news is there are times where, and of course, after the 100 milliamps, I'll crank it up as needed safely. But if there's a short circuit, then, or something goes way wrong, that power supply will go, nope, we're not going to blow you up. And that keeps everything sane while things are very unknown. Now, with that said, anytime I have a brand new circuit that I've never tested before, I always check power and ground, a continuity test. I want to see how much resistance there is between the two, because there should be some. And if I get a beep or a very, very low impedance reading off that, then I know there's a short. And so I definitely don't want to plug the thing in, because that's when we start blowing stuff up. So anyhow, I highly recommend a real deal power supply if you can afford it. And this one's fancy because it, like I said, has current limiting and a billion other things that most people don't need. But there are plenty of Amazon power supplies that have current limiting. So definitely check those out, and do yourself a favor and power the board externally. And what I mean by that is, imagine your Arduino Uno is not the how do I want to say this? He's just the brains. He's not the brawn. Okay, and again, this applies for all microcontrollers. And so he is the brains, but you should have this bigger board. And I kind of do that. Can you see my elephant board? Basically, I mount all my PCBs to this piece of plywood. The idea would be power comes into this thing, and it's beefy. It's a laptop power supply, or that's probably a bad example. They're like 19 volts. But anyway, you have a power supply with some serious beef that can handle whatever it needs, whatever it gets asked of it. And that way you don't actually push too much current through your Arduino in any way. Because a lot of times it's not just Arduino, there's a voltage regulator. Of course, we call it Arduino because it's a full package. You have the microcontroller is just the chip. And then you have a crystal, you might have some capacitors, you might have a few reset switch type things, you might have a voltage regulator. And so if you overload that voltage regulator, you pull too much current through it, you'll blow the regulator. And in your mind, you'll say your Arduino Uno is dead, but it turns out it's just the regulator's dead, and you could replace those for like 10 cents if you're willing. But so just keep these in mind, that you never really want to be powering your device from either really the computer or the Arduino itself. Now, with that said, the USB, like USB-B, USB 2.0, that's what I meant to say. It can push, I think it's 500 milliamps through, but that's supposed to be the spec. So 500 milliamps is pretty good. Now, if you overload it, you short a circuit, you pull too much current, then your Windows computer is going to be mad. And you don't ever want to blow up your motherboard. But they have protection on those. It's pretty good though, because I've seen that USB malfunction thing. I've seen that message so many times. But sometimes you have to restart your computer just to reset that message. So yeah, I don't know. Just be careful with all that. But when in doubt, use an external power supply, and I highly recommend that approach. Okay. Let's see. How much do we want to talk about here this week? I guess we're doing okay. Do we have time? We're 20 minutes in. Oh, we'll keep going. Okay, so this week I had a job interview, and they asked me how I was a Python, and my response was, I love Python. I do. In about 2016, I was using it a lot. I had a college class, and after that, I was the teacher's assistant and the teacher's assistant, and I was going around helping people in their labs and stuff, making the big bucks. But I was doing Python every day. I was used to it, and it's been a few years, and I really haven't touched it hardly at all. I did a few tiny little things, but I hadn't touched it in a while. I was like, well, if I'm going to imply that I've done a lot of Python and that I love Python, I probably should be good at it. And so all I had to do, I set a tiny little task. I'm going to open up a spreadsheet, and I'm going to convert a bunch of Fahrenheit numbers to Celsius numbers. This straight up exercise like you'd see in one of the textbooks for Python. And of course I wanted to save the file again. And it took me like an hour and a half. I thought I'd be done in 4 minutes, and almost all of it was fighting through Python's integers to string conversions. If you have a string, which is strings or letters, characters, A, B, C, D, and integers are get more like 1, 2, 3s, numbers, bouncing back and forth. They basically have an entire list, entire way of working on strings, and an entire way of working with numbers. And the two, you just can't combine them. And it's if you have a situation that deviates from anything you'd see on the internet, like a guide that are already working code, then forget about it. And so I went down that rabbit hole, and you find specific things that work for strings, specific things that work for integers and numbers. And I remember Python being so simple. Now, I've been doing C and C++ for a while now, and I'm gotten quite used to it. I don't find it overly, I guess, complicated. Like the language itself doesn't fight me too often. It's always like the registers or the chip I'm talking to is fighting me. But with Python, I had forgotten how bad this was. And I remembered once I started dealing with oh yeah, I've had these problems before. Unfortunately, I didn't have my magic cheat sheet to get me through it. So I'm probably going to have to do a few more of these that involve strings versus numbers. But man, so going back to Python wasn't as easy as I hoped. But I'm hoping just by knocking that little bit of a rust off, I'll be good to go. But it is funny when you remember back like a language being really easy to deal with, and suddenly it's not easy to deal with, and then you're like, what in the hell? And you start feeling like a piece of junk, and you question your own abilities and all that stuff. But we fought through it. So I guess that other lesson was before they actually hire you or test you, you might want to make sure you can do what you say you could. Granted, I didn't actually say I could. I just said I love Python. Quickly, this was on the Macrofab Engineering Podcast, and Parker talked about it on Twitter too, about something called eGas. Porsche has this terribly named eGas, which sounds like a digital gas, like a gas you could send through the mail, like email or download, I guess. But anyway, Porsche has this new gas that it's supposed to cause a internal combustion engine to have the exact same amount of emissions as an electric motor car. Like, isn't this fun? So, right now it's like $33 a gallon, and of course they're only making it in small quantities, and it's all a lot of theoretical stuff, and there's a million things that could go wrong with it. But Porsche is formally making the claim that they can do it on a small scale, so we will see with the big scale how that works out. And I've heard different takes on this, like it might not have that same natural lubricant that gasoline does. But if nothing else, people are working on other ways, as I said on Twitter, of skinning this CO2 cat. And, people, it's funny because electric cars, 10 years ago were a total joke. I mean, Tesla had them, but no one cared. And then somewhere in there, like 5 years ago maybe, people decided, like the universe decided that Tesla was cool. Like, all right, good, Tesla's cool now. And so now we've switched into, I could even see the, certain sides. If you're not driving an electric car, then you can go yourself. And that's a real possibility. People talk that way now. They're like, like electric cars are the future. And it's like, well, they are slow to charge. And if gas could suddenly just not have the same, like, if we solved the CO2 problem with gas, it's like, I'm cool with gas. Like, I don't have an allegiance to electric motors or internal combustion engine cars. But I could just imagine people flipping out and still be like, no, this is still crap. We are on Team Electric Car now. And like you switched and oversimplified the argument, or you've even forgotten why you switched to electric to begin with. We'll see. There's always three nutty, people that take something wrong on the internet. And I'm probably focused on them right now. But either way, I'm anxious to see how many people hate e-gas because it's not electric. We shall see. All right, I'm going to keep pushing here. Let's see, where were we at here? About 25 minutes. I like to keep these about 30 minutes for you and me. I saw Knipex, Knipex Tools. They have a pair of flush cut wire cutters. I think they're flush cut. The wire cutters that will catch the lead, the wire you're cutting. Like if you're cutting off the pins off of a resistor or whatever, I kind of look forward to it because it's an adventure. It's exciting when you cut that pin off an LED, we'll say, and you click it, and then like does it stay where it should, sort of, or does it fly in your eyeball? Like, will this be the one where I lose my left eye? I always wonder that because it's always a mystery. And I often, when I cut components, I will close my eyes just because I don't want to lose one. But Knipex Tools has invented this pair of pliers, wire cutters. You cut it, and it catches the wire, it catches the lead that would normally fly off. It stays right there. It has some kind of little system. Pretty neat. So if you get bored, check it out. I'm not going to run out and buy them. They look expensive. If there's videos about the tools you're looking at, you probably can't afford them. That's the old rule, I think. Okay. Oh, I didn't get to talk about this. This was the big breakthrough. I got distracted by all that noise because I had to redo my damn podcast here. My Reagan's Revenge, I've been pushing hard on software because I got the hardware at a state where once the code's ready, I got to shove it in a box. And in theory, it's not done, but this prototype's done. Well, several months ago, I was in PCB mode. I was like, I got the software good enough on my Elephant board, which is just nothing but dev boards and breadboard wire. It's a mess. And I got the code pretty good, but the code wasn't done. And I knew it wasn't done. But I'd read all the data sheets. The features, I had them pretty good. Everything was looking good. I was pretty confident about where we were, where the code would only need minimal changes and whatnot. Add a few features, turn on this, turn on that, and off we go. We're good. Well, the software wasn't done. And so therefore, the features that I thought, like my synth has two sides, it has a modulator and a carrier. Well, there was features that I thought belonged to both. It turned out there's a master that controls both of them. There's no individual control. Long story short is I have like 3 or 4 buttons and switches that don't need to be there on each side. So we're talking like 8 that just need to be gone and moved around. It's a long story short of saying that I thought I had all my features locked down. I did not have my features locked down because the data sheets weren't as clear as I thought they were, or I wasn't as sure as I thought it was. I was still in guess mode. I should have, before I started any hardware, I should have made sure my code couldn't have gotten any better. And, or at least if I had any thing on my list for coding, I should have taken care of it. Now, you could argue there, efficiency and tightening this and up and, making the code nicer, more modular, things like that, fine. But functionally wise, I did not guarantee that every function in my code was consistent with the hardware that I designed. And so now the code has changed immensely this week because I figured out that some of these features don't make sense where they are now, or they're not what I thought they were, didn't have the same demands that I thought they did. And so now my hardware is basically almost worthless, we'll say. Now, I knew this was a prototype. This is a prototype, let's say, it's version 2 with, the breadboard mess being version 1. But let's just say this, all that work that went into the PCBs for Rev 2, now I've got to rethink all of those and see where I messed up. The shape of the front panel is going to be different. It's not going to be near as tall. But it might need to be wider. Maybe I need to turn things. It's just caused a chain reaction of events where you have to start somewhere when you make a product. So, for me, I started with the data sheet, and I said, okay, here's the features it has. We can control, well, octave, for example. It sure looks like you can control that on both the modulator and carrier. Cool. Like, basically 2/2 of a channel, or 2 things that add up to make a channel. I just ran with it and never questioned whether that was correct or not. And, you iterate, and so you change some code, and then you change your front panel, and then you change some code, and then you change your hardware. And you can't just design one all the way unless you just know. In my case, I want to do everything that my chip's capable of. And so I had some not misgivings. I had made some mistakes on what the chip was capable of. And of course, the data sheets from 1988 or whatever, they're not clear. You can tell it's almost a different language then. It's very interesting. But yeah, there's not a strong attempt to convey knowledge through that. It's like, what else is the point of a data sheet? I don't know. So yeah, I guess the lesson for me though is commit as far as possible to the thing that's holding you back. In other words, I should have taken that software as far as I possibly could. And I already know what happened. I got the software pretty good. The synth is making noise, and I could control a few parameters. Cool. Only need a few little things left. I got bored doing software. And actually, I've been doing nothing but software for like 2 or 3 weeks now. That's what it feels like. And I'm kind of sick of doing it. Did you guys hear that? My belly just went crazy. I got sick of doing it, and so I didn't want to have to do any more. And so I said, you know what? I'm bored with software. I am going to go to KiCad and make some circuit boards, which is really where I wanted to be anyway. But so I did my circuit boards before the code was all done. And so now we kind of have all that work that went into the previous ones was practice. That's what it boils down to. And practice is good. But sometimes you want to practice and get paid for it in a sense. So my advice to you, if you're not sure what the hardware needs, get the software done, or vice versa. It's very complicated because you do have to balance the 3, the electronics, hardware, the coding, and the form factor, the actual case it's going to go in. All these matter. So I'm back to the drawing board on all that. And a lot of what I did is now obsolete, and I have some soul searching to do. And in fact, some of these features that I thought we had, that the data sheet implied or said we had, but I didn't know about the gotchas. And now the synth itself, I'm kind of like a question, like, this is a lot more bare bones than I realized. I thought we were going to have a lot more stuff to play with on here. But now that I gutted 3 or 4 things, it's suddenly, I don't know. We'll see where it goes. Maybe I can make it interesting. We'll see. But at the moment, I'm not so sure. And all this could have been dealt with months ago if I would have pushed through and got the coding as done as I possibly could. So that's my advice, is get your coding done. The free thing, the thing that you don't have to wait for to come in from China, or the thing you don't have to make on your CNC. Do that stuff last, or at least push it off as much as you can. All right, guys. Yeah, we just kind of ran it incoherently again. I had no real topic. We just had a lot of little topics. So if you liked it, please hit like your YouTube kind. I don't have, I'm getting I think I had 68 plays last month, which, we're just getting started. 68 plays will not pay the bills. If we were at 128 or whatever was it, 136 plays next month, I'd be in trouble. That's bad. So we got to get this channel going. So click like if you liked it, and leave a comment. If you can just stand this at all, leave a comment. I'm cool if you suck. I would take anything right now. I'm just desperate to get this channel taken off and going. And of course, this was a podcast. This wasn't intended necessarily to be a YouTube video. But so you can always subscribe on Electron Injection or on YouTube, or on iTunes and Apple and all, Stitcher, all that stuff. You can go to electroninjection.com if you need to find it there. So anyway, thanks for listening. I hope you guys like it. If you have any questions or ideas for future videos or guests, if you want to be a guest, yell at me. We're just trying to get this damn thing going before it's too late. Out.